Alright, question number 3. So the electricity coming from power plants into your house is called alternating current, or AC. This means that the direction of current flowing in a circuit is constantly switching back and forth. In Canada, the current makes 60 complete cycles each second. The voltage can be modeled as a function of time using the sine function. V is equal to 170 sine 120 pi t. So question number A is, or I guess letter A is, what is the period of the current in Canada? B is graph the voltage function over 2 cycles. This one we'll just use technology. And C is, suppose you want to switch on a heat lamp for an outdoor patio. If the heat lamp requires 110 voltages to start up, determine the time required for the voltage to first reach 110 volts. Alright, so A, here we're looking for the period of the current in Canada. And so if you guys remember, you guys can either look at your, use your equation, y or v is equal to 170 sine 120 pi over t, or you could also get it from, in Canada the current makes 60 complete cycles each second. So if we just want to go the easier way, we could use our period equation. So period is equal to 2 pi divided by the absolute value of b. And we should find that our period is equal to 2 pi divided by, and our little value here is 120 pi. And what we should find out is that our period here is equal to 1 over 60. Once when you cancel out the pi's here cancel out, and 2 divided by 120 can get reduced to 1 over 60. So our for A, what is the period of the current in Canada? That is equal to 1 over 60. Alright, so for question B, we need to graph the voltage function over 2 cycles. We can just do this one using technology, so I'm going to pull up my graphing calculator here. And here we can just use y is equal to 170 times the sine of 120 pi. And our value, I think it still works if it's in t, if not, we can use, just replace it with x. We'll see what happens there. So you ladies are going to have to adjust your windows. I believe with your calculators you should be able to. This is just a really, really crazy graph. You ladies hopefully should be able to adjust this. If not, I will. I'm going to do a table of values. I'll pause the video and write it out onto our Word document there. I'm assuming that you ladies can change your I guess your screen, your windows. You can change the domain to a certain thing. That way you can get certain values. With this one, obviously it's not the best. It's an online graphing calculator, so I'm going to have to do this one out by hand. So I'm going to quickly pause the video. I will do a table of values. I'll graph it. This one I guess I have to use Paint for, so keep it, or I guess bear with me ladies while I attempt to do this. So you guys should be able to figure this out. Do this on your own, and I'm going to quickly do it with Paint. Alright, so hopefully ladies had a quick second to pause that video, try it out for yourself here. But so this is what I got for my graph. Actually, I found, who would have thought that Paint can actually do some nice lines here, so clearly I didn't freehand that one. Looks a whole lot nicer. I kind of like that. Maybe I'll start doing some more with Paint. Anyway, so here's my table of values here. So whenever I put in t, just a couple of quick points here. When I put in 0 for t, I got v was equal to 0. When I chose 1 over 240, I got v was equal to 170. I chose those small values. I used kind of the period here as my little reference point here, so I tried to pick values, 4 values here that would give me enough data to plot it. So I took half of it, and I just kept getting really smaller values that I kind of knew would fit really nicely with our period there. So that's kind of how I chose those values there. And then I graphed them, and this here, we only had to graph for 2 periods, or 2 rotations. So this is what my graph here will look like. So if you notice that here we're at 0, 0, and then we're at 1 over 240, and y is at 170, and then we're back down to the x-axis at x is equal to, or I guess that'd be our t is equal to 1 over 20, and so on. So there's a nice little wonderful graph there. Alright, I'm just going to quickly delete this here so that way we can do C. Alright, so C says, suppose you want to switch on a heat lamp for an outdoor patio. If the heat lamp requires 110 volts to start up, determine the time required for the voltage to reach 110 voltages. So there's some different options you can do. You can actually plug this into your equation, or we can look on our wonderful graph that we've made right here. And so whenever it's at 110, so we're going to be looking approximately right about this little area here. And if you guys were able to use your calculators, you should hopefully be able to find a point there. One thing that you also could do is actually put it into your equation. You should get that value there. But one thing to note is we're not going to be using all 4 of these values. We just want to start it up. So right when we first start, we're starting at 0, and then, oops, I don't want to be moving this. We're going from here and going all the way up to 110. So wherever that value there is at 110, we should be able to find it there. All right, and though I'm going to solve this out by the equation. This graph, it's a little bit hard to see. It's a little bit hard to figure it out to be super exact there. So what I'm going to do is I'm going to put this into our equation. So here we're given that V is equal to 110, and that is equal to 170 sine times 120 pi times t. That looks like pit, but it's pi, not pit. Okay, so then we're going to solve for t here, and this here overall will be in brackets. They're all multiplying, so they're all one function. So I just put those there to help if that at all helps to see that. So first of all, we're going to get, we need to isolate this term here, the sine of 120 pi times t. So I need to get rid of this 170, so to do that I'm going to divide. So we have 110, divide that by 170, and that is equal to sine of 120 times pi times t. Okay, so next what I want to do is I can't do anything with inside here yet because it's all still one little function. It's all has to do with our sine here, so we need to get rid of sine, so we're going to do that opposite operation there. So we have sine inverse of 110, divide that by 170, and that is equal to 120 times pi times t. If you wanted to, ladies, you could actually divide 110 divided by 170, but I don't believe you get a nice value. Yeah, you get this like crazy decimal. It's like 0.64705, blah, blah, blah. And you don't want to be rounding because it will affect your answer overall. So if you leave it as this fraction and then put it all into your calculator, I guess at the very end, then that would be fine. So, so I'm just going to leave it this way just so I can get the most accurate answer. And so for our next step, we want to get t by itself, so we can divide here by 120 pi on both sides. So what we'll find out is that we will have 1 divided by 120 pi times that by the sine inverse of 110, divide that by 170, and that should equal to t. Now what you guys can do is put this all into your calculator. Just do this all at once, that way you're not left with any decimals, you're not rounding. It's just easier just to do this all in one step. And we should find that t here is equal to 0.0018666676, blah, 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 and we'll just round to the nearest, let's say 1,000, so we'll get t is equal to 0.002, okay? And it doesn't really say what to round it to, so let's just round it to this number here. I'll give you an actual number there to round it to, but that should be good. Hopefully looking at your graph, if you use your graphing technology, you should hopefully find that it's somewhere close to there. This one being in fractions, it's kind of crazy, but yeah, it's a really short time interval there, and I guess time, we should give our units there, so be 0.002 seconds, so it happens pretty quickly. So hopefully you can see that from your graph. If not, you guys can just solve it using your equations here like we just did. Alright, so hopefully that's alright there for you, ladies. So let's move on to question number 4. And so for this one, we're not going to be dealing with any graphing. Yikes. Or, well, I guess, thank God. Yes, no more graphing. But so for this one, we just want to write a function that models the average temperature each month in Whitehorse, Yukon. Alright, so for this one, it doesn't matter. It doesn't say to write both of them. So what I would accept is if you guys just made one equation or a sinusoidal function and kind of just call their quits from there. So just do one. If you wanted to, you could plot the points using technology. If not, that's okay. You don't really need to. It helps kind of, I guess, see if your what you guys graph is actually right, but you really don't need to. So I won't, and then I'll show you guys the process of, you know, if you don't want to graph it, this is what we're going to do. So what I'm going to do is I'm going to pick a sinusoidal function. Just remember, if you guys choose one, it would look a little bit different than the other, but for the most part they should be the same. If you graph both your sine and your cosine, they should be the exact same line there, so you guys can try that one out. I'm going to pick, we're going to use the cosine function here for this example. So here I have y is equal to a times cosine of b times that by x minus c, and that is plus d. So remember, this is just our general standard equation for our cosine function here. And so what we need to do is we need to find a, b, c, and d. And if you guys recall, our a is equal to our amplitude, which is equal to the maximum value minus your minimum, and that's all divided by 2. And remember, it's the amplitude, so it's going to be an absolute value distance. So if you guys need to, I guess we'll find out here pretty soon whether or not we need to use it, but just remember, it's always that positive value there. Okay, so we can grab these values here from our table, and if you look, our maximum here, that is just our highest value there, and it looks like we got our highest value there would be 14. And our minimum is going to be our smallest value there, and if we're looking through our table here, looks like it's going to be negative 18.4. So subtract negative 18.4, and that is all divided by 2. When you guys put that into your calculators, so 14, add 18.4, divide that by 2, and our overall answer there should be 16.2. Now we need to find b, which is our period. And so that equation is the period is equal to, that's going to be equal to 2 pi divided by the absolute value of b. And this is when we're dealing with it in radians. We're not dealing with, I know this here does say degrees Celsius, but these ones here are clearly not, we're not going to be dealing with degrees in this one here. So maybe for, if I ever give you a question like this, I'll actually tell you what kind of domain that's going to be in. But so this one here is going to be in radians, and we don't know what our value b is, but our period, all of this happens over the time period of one year, which is also equal to 12 months. So we'll do 12 months is equal to 2 pi over b. And from here we just solve for our unknown b, and so you can do that by, if you guys want to, it'd be dividing or multiplying by b to get it up into the top fraction, and then dividing by 12, or if you guys want to see the steps here, so we'd have 12b is equal to 2 pi. From there we'd go to divide by 12, so we have b is equal to 2 pi, divide that by 12, and finally our value here is that b is equal to pi over 6 once we reduce that fraction. Cool stuff. Alright, so now we need to find our c value, which is your phase shift, which is how much did your graph move from, or either to the left or to the right. So I'm just going to quickly pull up our, so here I just kind of grabbed, this is approximately what it would look like just using the data value that we have from our table. So looking at it, our maximum here is at 7 and 14, which we were given. And we need to know how much this value here moved, because remember, our cosine normally starts at about this value here, so we just need to look at how much did it move to the left or to the right from our starting position. So here your distance is from 0, and it goes all the way to x is equal to 7. So we know that c is there equal to 7. How much did it move to the left or to the right? It moved 7 units to the right, so that means it's a positive 7. So c there is equal to 7, and just remember, when you're putting that into your equation, it's going to be x minus 7, but we'll get to that when the time comes. I'm going to quickly flip over to our third video. Oh my goodness, but I promise you'll be really, really short, okay?